Hello everyone and welcome to our video today where we will be talking about Organic Chemistry Chapter 1, Nomenclature and Functional Groups. So there's a lot of basic information to cover in this first chapter that we build upon in the rest of the organic chemistry for the MCAT. So let's get right into it. We have, the IUPAC naming steps, and that's basically the nomenclature part of this chapter. So first, you need to find the parent chain, which is the longest chain with the highest priority. And we'll go through an example quickly afterwards, but let me just go through the steps first. So first you identify the parent chain, so you find the highest priority, and you have the longest chain with the highest priority. Then you number the chain so that the highest priority functional group gets the lowest number. So if we were going to label this down here, we have the highest priority functional group on here is this hydroxyl group, right? So we can either start counting from here or start counting from here. But to number the chain, we want the highest priority functional group to get the lowest number. So we would start counting from here so that this group gets 1, 2. Instead of it being 1, 2, 3, 4, 5, 6. That would be incorrect. You want the highest priority functional group to have the lowest number. So we would number it 1, 2, 3, 4, 5, 6, 7. Then you would name the substituents with prefixes. So in this case, we have a alkane right here, right? Which is 1 carbon, it's a methyl. And that is on the 1, 2, 3, 4, 5th. The 5th carbon has this methyl. So we have 5-methyl, 2-heptanol. So we get this last part of the chain the last part of the name by counting. So we had 7 in total. So hept is the prefix for that. So 1, 2, 3, 4, 5, 6, 7. So that's why we have hept. And then it would take on this suffix right here because the hydroxyl group is the highest priority functional group that we have. So that is how we would have 5-methyl 2-heptanol. 1, 2, 3, 4, 5, 6, 7. On the 5th, there's a methyl, and the highest priority functional group is on the 2nd carbon, and it is an alcohol group, which means we would have OL as the ending. So that's just the basic nomenclature. Definitely go through some other examples. Next, we have alcohols and amines. So there you can have primary, secondary, or tertiary alcohols and amines. So what that means is basically what this for alcohols, what that means is what this OH group is connected to. So in this case, it's a primary alcohol because this OH group is only connected to 1 carbon. This secondary alcohol, this OH group is connected to 2 carbons. And finally, tertiary alcohol, this alcohol group is connected to 1, 2, 3 carbons, which makes it a tertiary alcohol. And for amines, it's a similar idea, but it's how many carbons the nitrogen is attached to. So here we have a primary, I don't know if you can see it. There we go. Here we have a primary amine because this nitrogen is attached to only 1 carbon and 2 hydrogens. Here we have a secondary amine because we have nitrogen attached to 1, 2 carbons. And finally, we have a tertiary amine where this nitrogen is attached to 3 carbons. So that's just the basics there. Next, let's go into specific functional groups. So we have hydrocarbons as a big one. So hydrocarbons, you can have alkanes, which are single bonds. We would have alkenes, which are double bonds, and alkynes that have triple bonds. And the endings of these words are actually what their suffixes would be. So we have alkane, we have -ene, and -ine, okay? So those would be what you would use in the naming conventions. And just for reference, these straight chain alkanes, you start with methane, that's 1 carbon, ethane would be 2, propane would be 3, butane would be 4, then you have pentane, hexane, heptane, and octane, and so on. So those are just for straight alkanes, okay? And it would just kind of look like this. So this is just a chain of hydrocarbons. right? So however many carbons we have, let's count. 1, 2, 3, 4, 5, 6, 7, which means this would be heptane. All right. So next, let's look at our alcohols. So our alcohols, oops, sorry about that. Our alcohols contain an OH group. They have a prefix of hydroxy and a suffix of ol. They are a higher priority group than alkynes. So once you go through, when we were talking about the highest priority functional group, this is the order. Hydrocarbons, then alcohols are higher priority than that. Aldehydes and ketones are higher priority than alcohols, and then carboxylic acids are higher priority than the aldehydes and ketones. So it is this order of priority of functional groups to determine what would be your parent chain. But back to alcohols. So alcohols have a higher priority than alkynes. Diols contain 2 hydroxyl groups, so diols, 2 ols, right? That makes sense. And a geminol is if it is on the same carbon. If the 2 hydroxyl groups are coming from the same carbon. A vicinol diol would be if the hydroxyl groups are coming from adjacent carbons. So some vocab in there. Next, we have our aldehydes and ketones. So with this, that means that they both contain a carbonyl, which is a carbon double bonded to an oxygen. So aldehydes and ketones both contain a carbonyl carbon. And a carbonyl group. So we have aldehydes, which you have an R attached to a carbon, double bonded to the O up here. This is our carbonyl carbon attached to a hydrogen. So this would be the carbonyl at the end, at the terminal of this chain, right? Is the only way you would have a hydrogen here. And a ketone is very similar, but it is not at the terminal. It would be connected to the rest, another R group down here. So just to note what those functional groups are, the ketone has a suffix of -one, and aldehydes have a suffix of -al. Okay. Next, we have carboxylic acids and their derivatives. So a carboxylic acid, again, is a step up from the aldehydes and ketones. We have an R group attached to a carbonyl carbon, but here, instead of it just being attached to a hydrogen or an R group, it's attached to an OH group, which gives us this acidic property. So we have the, again, a carboxylic acid is this whole structure right here. It is the highest priority of functional groups. And the suffix would be oic acid at the end. So if it was the highest priority functional group, right, and it is in a molecule, the molecule would end with oic acid. Then we also have derivatives of carboxylic acids, and that includes esters and amides. So the esters is when this OH group is replaced with an OR, okay? And then we have amides, which we have the OH in the carboxylic acid that would actually be replaced with an amino group. So those are just 2 variations, 2 derivatives of the carboxylic acids, but definitely recognize all of these drawings, be able to tell what the functional groups are, as well as their prefixes and suffixes. I believe that is everything for this video, so thank you for tuning in. If you have any questions, put them below, and otherwise we'll see you in the next video.